Hi everyone, and welcome to our video on an application of optimization where we have business problems involved. Okay, so here's our summary of certain cost, profit, revenue type scenarios. And in this scenario, let's break it down. Okay, so we have these as our reference. So in example 3, it says if the price of a dog toy is P of Q dollars, then Q 100 dog toys will be sold. If the price is P of Q equals 400 minus Q over 20, what is the maximum revenue? All right, so this is using our revenue. Here, that's the second bullet right there, this one. Revenue, so they use Q, that's okay, so and that's what we have here, is your price times your quantity. Okay, so let's go ahead and set that up. So we have the revenue of Q is your price of Q times, this is just Q. So here I'm using the function notation times just Q. So here the price was not in function notation. Here it is, so I'm using their notation. So either way, let's go ahead and put parentheses around it and show that we will be subbing in that. Okay, so this is R of Q is equal to the price, the 400 minus Q over 20 times Q. Oops, let's keep that. There we go. Okay, and then now it's getting ready to set up. So if we're trying to maximize revenue, so I didn't underline that. Let me make sure I want to really underline it. I want to maximize revenue. We know whenever we see maximize or minimize, we want the function that they're considering, which is what we have now. And then afterwards, to find its derivative and set it equal to 0. Okay, so this is no big deal. I'm going to distribute the Q. So we have R of Q is 400 Q minus Q squared over 20. And then now let's find its derivative. So R prime of Q is 400 minus, this would be eventually Q over 10. And then now all I want to do is set this equal to 0. Let's put it up here. 0 is equal to 400 minus Q over 10. And then now we can solve. So I'm going to add the Q over 10 over. And we have Q over 10 equals 400. And then now I could just multiply by 10 to get the Q. So Q is 4,000. Okay, so did we answer it? So they said if the price is this, what is the maximum revenue? Okay, so Q, so and this is 4,100 really. Okay, so a little strange, but we'll just use our 4,000. And now we could just plug it back into our revenue equation right there. Okay, so all we're going to do is just plug in R of 4,000. Actually, let's put it, let's go ahead and do it in a different color, and we'll do it right here. Okay, so our max revenue, now we can do it, is R of 4,000. All right, R 4,000 equals the 400 minus 4,000 over 20, like that, and then times 4,000. Okay, so I'm going to squeeze that in, 4,000. Okay, see, we not the best, sorry, but it looks okay. And then now we just simplify. Okay, so 4,000 minus 4,000. So this is now just calculator at this point. Okay, so let's go ahead and type that in. Let's do, so I'm going to do the 4,000 divided by 20. And then I could do 400 minus that 200. And then that is 200. And then times by 4,000. And we get 800,000. Okay, so that's it. So our maximum revenue. Our maximum revenue was 800,000. And that's in dollars. There we go. Okay, so that's it. There we go. So usually the business ones are a little easier than like the geometry ones that we had from before, the rectangles. So it's usually just use the equation and plug it in and go. All right, so let's do one other. So on this, it says a company manufactures and sells X cell phones per week. The weekly price, demand, and cost equations are right here. What price should the company charge for the phones, and how many phones should be produced to maximize the weekly profit? And then what is the weekly profit? Okay, so they want us, let's underline it, maximize They want us to maximize profit. So I'm going to abbreviate. Let's maximize profit. Well, we know profit, and it looks like they're using x here, so our profit function would be p of x is the revenue function minus the cost function. All right, and then they have the cost function already ready, and our revenue is kind of repeated where we're going to take this price and times it by the quantity. So remember, your revenue is price times quantity. Our price is that, and our quantity looks like it's x. So they're talking about x cell phones. So we would have 400 minus 0.1x times x. Okay, so this is our revenue. So let's go ahead and distribute it. So we're just doing our revenue kind of scratch work to the side. So we have our revenue of x is 400x minus 0.1x squared. Okay, so it looks like I can plug that in to this. So let's go ahead and write that in. 400x minus 0.1x squared. And then we have our minus. Let me write my p of x over here. P of x equals, okay, so the revenue minus the cost. The cost was given to us immediately, 200 or 25,000 minus 135x, like that. Okay, and then now all this is we're going to simplify and take our derivative. So our p of x is, all right, so this negative would distribute. Be careful. So we'd have 400x minus 0.1x squared minus 25,000 plus 135x. Okay, so the minus distributed through there. Oops, I wrote it down. Be careful, actually. So it was plus. I wrote minus plus. Okay, so that means that would have distributed, and that would become a minus. So make sure you write it down right. Yikes. Okay, so there we go. So now it's written down right. Okay, so the negative distributed, then now it's fixed. Okay, and then I'm going to rewrite our profit function so it's in descending order. So it looks like we have negative 0.1x squared. The 400x minus 135x would be plus 265x, and then minus 2,500, or 25,000. Wow, saying things wrong too. Okay, so minus 25,000 at the end. Okay, so this is the profit function, so we'll use this again eventually, but at this point, now I want the derivative. So our profit function, p prime of x, is negative 0.2x plus 265, and then that's it. Okay, so the derivative of constant 0. And then now I can set the derivative equal to 0. And that's what we do when we need to maximize or minimize anything. And we'll have negative 0.2x plus 265. And then from here, we can start to solve it. Okay, so it looks like I'm going to put this, let's go ahead. Well, I'll just keep it. I think I can squeeze it. I'm going to add that over to give us 0.2x equals 265. So I just added it over. And then, well, I would divide both by 0.2 at this point. And then that would give us, let's put x just to the side here. And then let me use my calculator. 265 divided by 0.2 gives us 1,325. Okay, so we have x equals 1,325. And those are cell phones. If we need our units. There we go. Okay, so did we answer what they wanted, though? So they said, what price should the company charge for the phones? Okay, so they wanted multiple things. What price should the company charge for the phones? And how many phones should be produced to maximize weekly profit? Okay, so we did find the price, or we did find the number of phones. That's that. Okay, so let's go ahead and call this number 1, and we'll put our answer here in red. Okay, so we know the number of phones. How many phones? There should be 1,325 phones. And then the price, well, the price is right here. Let's highlight it in pink. It's this equation. So that means I just need to plug that into that. Okay, so our price equation. Price is P equals 400 minus 0.1 times the 1325. So I'm just using my x value that I just found. And again, I'm just going to quickly go to my calculator. We've got 400 minus 0.1 times 1325. And it gives us 267.5. Okay, so that's our price then. Our price is 267.5. We'll put another 0 to show the cents. There's that. So we have the price. We have the number of phones. And then for number 2, they did say, what is the weekly profit? Number 2. Okay, so now I've got my profit equation, which is starred right there. Our profit equation, well, that would be plug in our x value into it, 1325. Goes into our profit equation. Again, that's starred. Let me go ahead and highlight the portion there. So I'm just going to change all those x's at this point. And then we'll just, again, use our calculator. Okay, so the 1325 is going in. I probably can't fit it all in one line there. Let's write it below. So negative 0.1 times 1325 getting squared plus 265 times 1325 minus 25,000. Okay, so that's all I need to do, and I just need to plug that into the calculator. Okay, so let's do that one more time. I'm just going to use my basic one that's already ready. Okay, so I have negative 0.1 times 1325 times 1325 to square it, plus 265 times 1325 minus 25123. And it gives us that. Okay, so $150,562.50. That's that. All right, so we found it. So our profit, I'm going to write it as profit in words, is equal to 150,150,562.50. There we go. Okay, so that's that. Okay, so with business ones, it's usually as long as we're good with knowing what the vocabulary is and using pretty much any of these types of scenarios. Once we have our equation set derivative equal to 0, and then from there we solve. Okay, so thanks for watching. If you have any questions, let me know. Otherwise, I'll see you next time.